Hello all, Morgan here. So it's a math day. We're going to be looking at some math problems. And these problems are all consequences of the ideal gas law. Now we remember that the ideal gas law says PV equals nRT. And we can do some rearranging with that, okay? We can recognize that PV equals mass over molecular weight, which is what N is, times RT, or that molecular weight must equal MRT over PV, which is a very, very useful form of the ideal gas law. Now, some of you might remember that density equals mass over volume. So molecular weight can equal density times RT over P. And we'll use both these equations a lot in what we do. Okay, so if we're looking for the density of carbon dioxide at STP, we're going to rearrange this and say density equals pressure times molecular weight over RT. So density equals. Now, the pressure at standard pressure is 1.00 atmospheres. Okay. Now, the molecular weight for carbon dioxide adds up to be 44.0 grams per mole. Right? R is 0.0821 liter atmosphere per mole Kelvin, and the temperature at standard temperature is 273 Kelvin. So the kelvins cancel. Atmospheres cancel. Okay, moles cancel. We have grams and liters left. That's pretty good. All right, and this comes out to be 1.96 grams per liter. Okay, so now, how about the density of some water vapor at 760 torr and 100 degrees? Density is still equal to pressure times molecular weight over RT. The pressure is 760 torr times the molecular weight. Well, for water, that is 18.02 grams per mole. R, to get rid of torr, we would use the value 62.4 liter torr per mole, okay? And the temperature converted to Kelvin is 373 Kelvin. Now, Kelvin is gone, moles is gone, torr is gone, grams over liters, and this is 0.588. So what this shows you is that as you increase the temperature, the density of a gas goes down. And that makes a lot of sense to us. Okay, so we're looking for the molar mass of a gas that has a density of 6.51 grams per liter at STP. Molecular weight is dRT over P. dRT over P, which equals, so I've got 6.51 grams per liter. R of 0.0821 liter atmosphere per mole K. The temperature at STP is 273 Kelvin, and the pressure is 1.00 atmospheres. All right, I see atmospheres, liters, Kelvin, all canceling, left in grams per mole. That's 146 when I add her up. Okay, now we have to do some work here involving a formula. The empirical formula is CHCl, and we want to know what the molecular formula is. So we need to know the molar mass based upon all this gas information. They give me volume, all its milliliters. I'll need to convert temperature, pressure, mass. Okay, so molecular weight equals MRT over PV based upon this right up there. So the mass is 0.80 grams. Okay. Now, since the pressure is 750 torr, I'm going to use 62.4 liter torr per mole K. The temperature is 373 Kelvin, but that 256 milliliters needs to be converted to liters, so that's 0.256 liters. Okay, now Kelvin's gone, torr is gone, liters gone. I got grams over moles. Now this equals, call it 97, paying attention to sig figs. Now does CHCl equal 97? Well, let's see, carbon's 12.01 plus hydrogen's 1.01 plus 35.45 for the chlorine, and that comes out to be about 48.5. So 48.5 into that goes twice, so the formula must be C2H2Cl2. All right. Now for a flashback. Percent composition to get an empirical formula before we do all this. So 46.2 grams of carbon and 53.8 grams nitrogen times 1 mole carbon, 12.01 grams carbon, 1 mole nitrogen, 14.01 grams nitrogen, equals 3.85 and 3.85. Okay, that's the same number. It's a 1-to-1 ratio. Divided by 3.85 equals 1. Divided by 3.85 equals 1. So the empirical formula here must be Cn. Okay? Now I can use this information to calculate its molecular weight. Molecular weight equals mRT over PV, which equals, now the mass is 1.05 grams. The pressure, I'm going to check the pressure, 751 torr, which means my R is going to be 62.4 liter torr per mole K. Temperature 25 Celsius is 298 K. All right. The volume is 0.500 liters. Liters is gone. Torr is gone. Kelvin's gone. So in grams per mole, this comes out to be 52. Now, does this equal 52? No way. 12 plus 14. So that's 26. Oh, well, 26 goes into 52 twice, doesn't it? So this must be C2N2. All right, folks. Brief little tour there through some interesting ideal gas law stuff involving density and molar mass. Thanks for tuning in. This is Morgan, signing off.